Good day to everyone. I'm Natanya Vincent A. Lubrica, and I'm representing my group composed of Mr. Carlo Valdez, Ms. Judel Canyo, and Mr. Ruben Rubia, and we are from the University of the Cordilleras, Baguio City. The title of our study is The Analysis of Dengue Cases Using Geographic Information System, or GIS, Evidence from Baguio City, Philippines. And before I go to our presentation, I would like to um, recognize our funding agency, which is the DOS TPCHRD, as well as CRHRDC. So, for the rationale of our study, dengue is a global epidemic affecting tropical and subtropical countries. So you can see the Philippines, other Southeast Asian country neighbors. You have here Africa and South America. Now, from the records of the World Health Organization back in 2000, we have about 500,000 global dengue cases. But after 20 years, the 500,000 figure now is 4.2 million in 2020. Locally, we have an increasing problem as well in the number of dengue cases in our locality like Baguio, because it was recorded by the Baguio City Health Services Office from January to August of 2021 that there is a 600% increase over the last year. Thus, the main objectives of our study was to analyze the dengue cases in Baguio City for the past 5 years vis-a-vis socio-demographic factors and physical attributes. And specifically, we can attain this by plotting dengue cases in Baguio City using this data from 2013 to 2017 and compiling or digitizing relevant thematic maps and various physical attributes, and putting this all together will now analyze the dengue statistics vis-a-vis the socio-demographic factors and physical attributes. Now it looks like this. It starts with the data gathering and ground truthing. From the socio-demographic data, then we get the physical attributes, then we clean it, standardize, normalize, and we use GIS processes like geoprocessing, spatial filter, and joins, and now we apply the algorithm, the clustering algorithm called the GETIS or G for the hotspot analysis. And at the end pipe of the analysis will be the use of the weight of evidence and the information value, which I will later define. So in our methodology, we use a GETIS ORD in treating the 2013 to 2017 data of the number of dengue cases in barangays to identify the hotspots. Now, after identifying the hotspots, we now use the weight of evidence, which is shown here, which determines the strength of independent variables, and the information values, which we use to reduce these independent variables and classify them, which are useful for modeling. Is it a weak predictor? You can see here numbers and ranges that defines the effect of the variable to the number of dengue cases happening in barangays. So for our results in discussion, you can see it here that we have maps. When we try to run this barangay map with the information on the number of dengue cases from 2013 to 2017, you can see barangays with the high cases of dengue. Okay, so we call it a dengue cluster. So you have hotspots and you have cold spots. And using this methodology, we were able also to identify the most significant barangay where the dengue is happening. Now, there's a lot of impact on this finding. wherein we can understand further why dengue is happening in that barangay, as well as analyze the variables. But aside from that, it has an effect on the policies. So what can we do? What programs can we do in these barangays to help this or to prevent dengue in these barangays? So going further, we have the following results and discussion, wherein we're able to identify strong predictors which include interconnected housing and urbanization, medium predictors of dengue, which includes land surface temperature, hydrology, and population density, and weak predictors, which include age and sex. And surprisingly, we were able to determine suspicious or too good to be true variables, which includes housing independence, soil, elevation, and land cover. Now, there's an explanation here. When we investigated these variables, since we use maps, there's a lot of generalization that happen in larger areas. Like, for instance, our soil map was based on the national level soil map. So which means that it reaches this level of being suspicious or too good to be true because we need to really localize the data for the information value to be more accurate. So as part of our conclusions and recommendations, we now recommend this as a utility model, this method of approach to understand the hotspots of any disease using the barangay maps and to be able to understand and cross analyze it with physical and socio-demographic characteristics. This can be a utility model. So interconnected houses and urbanization are strong predictors of dengue. You have rapid urbanization. It explains why, because rapid urbanization was observed in Baguio City from this length of time, from 2014 to 2019. And we were able to conclude that this GIS methodology that we have innovated provides the possibility of harmonizing existing data sets into more sensible evidence that can better inform policymakers into taking actions that promote health and prevent diseases. Thanks for listening. In behalf of my team and the University of the Cordilleras, good day to everyone.